Deep in the heart of reality, smaller than atoms, smaller than the tiniest fragments of matter we can imagine, lies a realm so bizarre that it makes science fiction look mundane. This is the quantum realm, where particles exist in multiple places simultaneously, where information travels faster than light, and where the very fabric of empty space bubbles with invisible energy. Tonight, we descend into this microscopic universe to uncover what truly exists when we strip away everything we think we know about reality. What you're about to discover will shatter every assumption you've made about how the world works. We'll explore a dimension where cause and effect break down, where particles can tunnel through walls, and where the simple act of observation changes the nature of reality itself. From virtual particles that pop into existence from absolute nothingness to quantum fields that permeate every corner of the universe. This journey will reveal the hidden machinery that drives everything from the fusion reactions in stars to the mysterious dark energy tearing our cosmos apart. But here's what makes this exploration truly extraordinary. The quantum realm isn't just some abstract theoretical playground for physicists. It's the fundamental layer of reality that governs every atom in your body, every photon of light hitting your eyes, and every chemical reaction keeping you alive. Understanding what exists in this microscopic universe doesn't just satisfy scientific curiosity, it reveals the true nature of existence itself. Prepare yourself for a journey that will challenge everything you believe about reality, because once you see what's hiding in the quantum realm, you'll never look at the world the same way again. Let's begin our descent into the impossible. Picture standing at the edge of the smallest possible scale of reality. You've shrunk down past molecules, past atoms, past even the nucleus and electrons. You're now entering a domain where the familiar rules of physics collapse entirely. This is the quantum realm, and it operates according to principles so alien that even Einstein called them spooky. At this scale, measured in units so small that comparing them to everyday objects becomes meaningless, we encounter the first shocking truth. What we call empty space isn't empty at all. It's seething with activity, crackling with energy, and teeming with particles that flash into existence and vanish in time frames shorter than anything the human mind can comprehend. The Casimir effect demonstrates this perfectly. When two metal plates are placed extremely close together in a vacuum, virtual particles push them together with measurable force, proving that empty space contains real energy. The energy density of these quantum fluctuations staggers the imagination. In a single cubic meter of empty space, the energy contained in virtual particles exceeds the mass energy of the sun. Think of reality not as a collection of solid objects moving through empty space, but as ripples and waves in an ocean of invisible fields. An electron isn't a tiny ball of matter. It's a localized disturbance in the electron field that extends throughout the universe. These virtual force-carrying particles pop into existence, deliver their message, and disappear so quickly that they exist below the threshold of direct observation. Quantum tunneling allows particles to pass through barriers that should be impenetrable, like a ball rolling through a solid wall. In stellar cores, atomic nuclei lack the energy needed to overcome their mutual electrical repulsion and fuse together. Classical physics says fusion should be impossible at the temperatures found in most stars, but quantum tunneling provides an escape route, allowing nuclei to effectively teleport through the energy barrier that separates them. The famous double-slit experiment demonstrates this mind-bending behavior perfectly. When individual electrons are fired at two parallel slits, each electron somehow passes through both slits simultaneously. But the moment you try to observe which slit the electron actually went through, the superposition collapses, and the electron behaves like a normal particle choosing only one path. Recent experiments have pushed superposition to larger and larger scales. Scientists have created superposition states involving thousands of atoms. When particles become quantum entangled, they form connections that transcend space and time. Measuring one particle instantly affects its entangled partner, regardless of the distance separating them. This effect has been demonstrated across thousands of kilometers, proving that the quantum realm operates according to principles that violate our understanding of locality and causality. Every quantum interaction leaves traces in the underlying field structure, creating an invisible record of events that persists long after the original particles have disappeared. Photosynthesis, the process that powers nearly all life on Earth, relies on quantum coherence to achieve its remarkable efficiency. Birds navigate using quantum entanglement in specialized proteins in their eyes, allowing them to literally see magnetic fields as patterns of light and shadow. Some scientists even propose that consciousness itself might emerge from quantum processes in the microtubules of brain cells. Quantum computers harness superposition and entanglement to perform calculations that would take classical computers longer than the age of the universe to complete. Quantum sensors can detect gravitational waves, magnetic fields, and other phenomena with sensitivities that approach the fundamental limits set by quantum mechanics itself. Quantum communication networks use entanglement to create unbreakable encryption systems. Any attempt to intercept the quantum-encoded information would immediately alert both sender and receiver. In the deepest layers of microscopic reality, information becomes more fundamental than matter or energy. Every quantum interaction processes information, stores it, and transmits it. If the quantum realm is processing information at the most fundamental level, then the universe itself might be a vast quantum computer running the program we call reality. At scales of 10 to the minus 35 meters and time intervals of 10 to the minus 44 seconds, the familiar concepts of space and time themselves begin to break down. The quantum realm reveals that reality is far more creative, flexible, and interconnected than our classical intuitions suggest. It's a domain where possibility takes precedence over certainty, where relationships matter more than individual objects, and where the act of observation fundamentally participates in creating what gets observed. As we prepare to explore even stranger aspects of quantum reality, we begin to see that the quantum realm isn't just the foundation of physics. It's the source code of reality itself, the invisible operating system that generates everything from atoms to galaxies to consciousness.